All right, welcome to the deep dive. Today we're going to be tackling something you brought to the table, and that's orthoses.
I think it's important to remember that orthoses are very carefully engineered tools. They're designed, they're made, and then fitted to help you manage functional limitations, disabilities. So it's a very personalized device.
Yeah, so then the person who would make this happen, the specialist, would be the orthotist.
Yeah.
So that would be the person who evaluates your needs, comes up with a design, fabricates the actual device, makes sure it fits correctly, and then, super important, teaches you how to use it and take care of it.
Yeah, that's a crucial part of the process.
Yeah. Now, I think it might be useful to kind of back up for a second and talk about the term orthosis itself.
Mm.
It might sound a bit clinical or even a bit intimidating, but it actually comes from the Greek word ortho, and it's actually a really simple concept. It just means straight, upright, or correct.
It's all about getting things back into the right position, so to speak.
Yeah. And an orthosis in its most basic form is a device that's often, you might call it a splint in a more casual sense, but it's designed to either keep things still, so we call that static, or it can help you have controlled movement, which would be dynamic.
Right. It's either about restricting unwanted movement or facilitating the right kind of movement.
Yeah. And it's important to keep in mind that orthosis is a much broader term than just brace, because it encompasses devices for dynamic control, not just basic stabilization.
Absolutely.
Now, this is something I found absolutely fascinating when I was going through your material. It turns out the idea of these supportive devices goes way, way back. You might think, oh, this is a modern invention, something from the 20th, 21st century. But archaeological finds actually tell a very different story. There's evidence of post-fracture supports found on mummies in ancient Egypt, dating back to about 2700 BC.
I know. Isn't that amazing? It really puts things into perspective, doesn't it? Even thousands of years ago, people were figuring out ways to support injuries.
Yeah, I mean, seriously, that's just mind-blowing to me. So going forward in time a little bit, what happened after those early Egyptian innovations?
Well, fast forward to around 370 BC, we have Hippocrates. He was using splints specifically to reduce pressure on those bony prominences, the parts that stick out.
Makes sense.
Yeah. And then in the Roman era, in the 2nd century AD, Galen started exploring dynamic orthoses, not just keeping things still. He was looking at ways to address things like scoliosis and kyphosis, which are spinal problems.
So already kind of expanding on that initial idea of just, rigid immobilization.
Exactly. And by the 1800s, orthoses had become a recognized and integrated part of orthopedic departments.
So kind of fully ingrained in the medical establishment by that point.
Precisely.
So let's kind of bring it back to the present day. If someone is using an orthosis today, what are they hoping to achieve? What are the key objectives of using these devices?
Well, the goals can vary quite a bit depending on the person and their specific situation. Sometimes an orthosis might be used to prevent a deformity from developing in the first place. Or it might be used to actually correct a deformity that's already present.
Like, I'm thinking about scoliosis in children, for example.
Exactly. And they're really important for pain management as well. You often see orthoses used to provide stability to joints or tendons, especially after an injury or surgery.
So like that classic wrist brace you might wear after a sprain.
Exactly. They can also help a weak limb function more effectively, kind of give it that extra support it needs.
So enhancing function rather than just restricting movement.
Yeah, and they can play a role in correcting or maintaining the proper alignment of joints, and even in reducing muscle tightness or spasticity, which we call inhibiting tone.
So really targeting those specific muscle imbalances that can occur.
And of course, they're crucial for protecting patients after surgery, preventing re-injury, and ultimately, the big goal is enabling people to have the greatest possible level of independence and function.
So kind of maximizing that quality of life.
Exactly. And in some cases, they can even facilitate movement, actually help people move better.
So it's not always about restricting movement, but it can actually be about enhancing it.
Precisely.
Now, thinking about you, our listener, if you were to need an orthosis, what would make for a really good one? What are the essential characteristics of an ideal device, keeping your potential needs and experiences in mind?
That's a really important question, and it really boils down to what works best for you in your daily life. The ideal orthosis has to be comfortable. If it's causing you pain or discomfort, you're less likely to wear it consistently.
Right, because it's got to fit into your life. It can't be this thing that's constantly nagging at you.
Right. It also should genuinely improve your function. It should make those everyday tasks easier to manage. Reducing the amount of energy it takes you to move is another big plus. You don't want the device itself to be making you tired.
Yeah, defeating the purpose a bit.
Exactly. Affordability is, unfortunately, a real consideration for many people,
Yeah.
and how easy it is to put on and take off independently is huge. If you're constantly struggling to get it on or off, it's going to be a barrier. And let's be honest, the way it looks can also influence whether someone is willing to wear it regularly.
Yeah, especially if you're younger, that can be a really, really important factor.
And lastly, of course, it needs to be durable. It needs to withstand the demands of your daily life. So there are a lot of factors to balance: comfort, improved function, energy efficiency, cost effectiveness, ease of use, aesthetics, and durability. It's a complex equation.
So it really is a tailored experience, finding the right orthosis for each person.
Absolutely. The design is deeply personal. The orthotist will consider your specific expectations, your daily routine, your overall lifestyle, your work environment, even the support you have from family and friends.
So not just the physical aspects, but the social and, kind of like the psychological aspects as well.
Exactly. The process starts with a thorough assessment of the physical problem, followed by the fabrication of the orthosis. And importantly, it needs to be part of your broader treatment plan. You'll get detailed instructions on how to care for both the device and your skin, how to integrate it into your daily activities, whether that's for getting around or for tasks at work.
So there's a whole education component as well. It's not just, here's the device, good luck.
Absolutely not. It's a very collaborative process.
So you've got the device, you're learning how to use it. What would be some specific functional improvements you'd hope to see as a result of using the orthosis? What are those functional goals?
The main functional goals are really about enhancing your overall quality of life. This could include improving your ability to move and get around, increasing your independence in everyday tasks, and making those activities of daily living easier. The orthosis should be easy for you to put on and take off, and you should be able to maintain good skin health and keep the device clean.
Yeah, those hygiene aspects are super important.
Absolutely. And the correct alignment that the orthosis provides is fundamental to its effectiveness. It's important that the device stays in place, without too much movement against your body.
So it's got to be snug and secure, but not too constricting, right?
Exactly. And a well-designed orthosis will minimize pressure on any sensitive areas, to prevent discomfort or skin issues. So it's a lot to consider.
It really sounds like it. Now, I'm curious about the science behind all of this. What are some of the core scientific principles that underpin how these devices work, how they're designed? What are the biomechanics involved?
Well, there are several fundamental biomechanical principles at play here. One of the most crucial is the three-point pressure system.
Okay, break that down for me.
Sure. So imagine you have a slightly bent ruler and you want to straighten it out.
I see where you're going with this. Okay.
You'd apply pressure in the opposite direction at the bend, right? And then you'd use your fingers above and below the bend to kind of control it and keep it straight. So you've got one main force correcting the problem and two counter forces providing control.
So if I'm thinking about my wrist brace again, it's applying pressure, let's say, to the back of my wrist to straighten it, and then it's got that counter pressure above and below the wrist to keep it stable.
Exactly. That's a perfect example. Another key principle is the total contact principle. The goal here is to distribute pressure evenly across the whole area where the orthosis is touching your body. By spreading out that pressure, we avoid having those concentrated points of high pressure, which can really make a difference in terms of comfort and preventing skin problems.
Yeah, it's all about spreading that load out.
Right. And then we have the partial weight transfer principle. This is often used in orthoses for the lower limbs, like leg braces. The idea is to shift some of your body weight off of an injured or painful area, allowing it to heal or reducing stress on it.
So it's like giving that area a bit of a break.
Exactly. The larger the surface area over which a force is applied, the lower the pressure. So a longer force arm and a wider surface area are both going to make an orthotic device more effective and more comfortable.
It's all about that leverage and spreading the force.
Precisely.
Now, I know from my research that getting the right orthosis isn't just about the device itself, but also about the team of people working together to make sure it's the best fit for you.
Absolutely. Orthotic care is a team effort. You'll likely be working with a physiotherapist, focusing on your rehab, improving your movement, your doctor, making the diagnosis and prescribing the orthosis, an occupational therapist helping you integrate the orthosis into your daily life, and, of course, the orthotist, who designs, creates, and fits the device. And maybe most importantly, you, the patient, are a central part of this team. Your feedback and your commitment to using the orthosis as prescribed are essential for a successful outcome.
So it's not just, passively receiving treatment. You're actively involved in the whole process.
Exactly.
So then what does that process look like? What's the typical journey for someone who needs an orthosis?
Well, there are usually three main phases in orthotic management. The first is evaluation. This involves a physical assessment, looking at things like your range of motion, your sensation, your muscle strength. They'll also assess your functional abilities, what you can and can't do, and even your psychological well-being, because adapting to an orthosis can have an emotional impact.
Right. It can be a big adjustment, especially if it's a long-term thing.
Absolutely. The second phase is the treatment plan and education. Here, the team works with you to set realistic goals, what you hope to achieve with the orthosis. You'll learn how to care for your skin, how to put the device on and take it off correctly, and how to use it safely in your daily life. The final phase is functional outcomes. This involves evaluating how well the orthosis is working. Is it comfortable? Is it helping you achieve your goals? How well have you incorporated it into your daily routine?
So it's that ongoing assessment and making sure it's actually meeting your needs.
Exactly.
So let's say your doctor decides you might benefit from an orthosis. What are some of the key things they consider when prescribing one? Especially thinking from your perspective as a listener, what are those practical considerations?
Well, they'll consider your individual abilities and needs, of course, the nature and severity of your impairment, any functional limitations you're experiencing, and any disabilities you have. They'll also consider whether your condition is permanent or likely to change, which might influence the type of orthosis chosen.
So if it's a temporary thing versus a lifelong condition.
Exactly. Your lifestyle is a big consideration, too.
Mhm.
Are you very active or more sedentary? Are you primarily mobile outside the home, what we call a community ambulator, or mostly within your home, a household ambulator?
Those are some terms I haven't heard before.
Yeah, there are important distinctions in orthotics. Your recreational activities and work demands are also really important in determining the best device.
It's all about context, right? It's got to fit into your life.
Absolutely. And then there are those other practicalities, the overall weight of the orthosis and your ability to manage that weight, the energy required to use it. Sadly, some people end up abandoning orthoses because they're just too energy demanding.
But you're trading one problem for another, almost.
Right. Your hand dexterity and your mental capacity are also considered. Can you physically manipulate the device to put it on and take it off? Do you understand how to use it correctly and safely? The tolerance of your skin to pressure is a major concern. We want to avoid skin breakdown and discomfort. And finally, the team might consider a temporary orthosis to see how you adapt to it, how likely you are to benefit from a more permanent one. It can help predict your potential for increased independence and can be cost-effective.
That trial period makes a lot of sense, just to see how you get on with it.
Absolutely.
Now, orthoses seem to have such a wide range of uses. It's amazing. So how are they generally categorized, based on what they're designed to do?
Well, one way to categorize them is by their primary purpose. We have functional orthoses, which are designed to assist or enhance movement. These often have features like levers, springs, or even small motors.
So like actually helping you move.
Exactly. Then we have static orthoses, which are primarily intended to restrict movement, to provide that rigid support when needed, like after surgery or a fracture. Then there are corrective orthoses, which aim to fix or improve deformities. These are often used in children and adolescents as their bodies are still growing. Think scoliosis braces or those used for hip dysplasia. And finally, we have immobilizer orthoses, which are used to limit movement in a specific area. These might be used in the trunk for spinal conditions, or in limbs after a fracture, or for pain management in conditions like arthritis, or even to manage spasticity.
So like a whole range of applications there.
Right, so you might have a simple sacroiliac orthosis, or SO for low back pain, or a more extensive thoracolumbo-sacral orthosis, or TLSO after spinal surgery. There's a whole range of them.
So it really is tailored to the specific area and the specific condition.
Precisely.
Now, another important way to classify orthoses is based on the materials they're made from, which seems like it would have a big impact on how it performs and feels.
Absolutely. The materials used have a huge impact on the orthosis's properties and how it functions. We have orthoses made from metal combined with leather or fabric, or with elastic components. Some are hybrid orthoses, blending metal with thermoplastics. Then you have thermoplastic orthoses, which are often semi-rigid, and finally rigid orthoses made from acrylic or polyester. Each material has its own pros and cons. Leather is great for liners and interfaces because it's soft and protects the skin. Steel is super strong, but heavy and prone to rusting. Aluminum is popular because it's strong, lightweight, and corrosion resistant. Titanium is even stronger and lighter than steel, but it's expensive. Magnesium is even lighter than titanium and also has good corrosion resistance. And then we have thermoplastics, which are amazing because they can be molded when heated and then become rigid as they cool.
So it's like custom fitting on a whole other level.
Exactly. Low temperature thermoplastics are great because the orthotist can actually mold them directly to your body. High temperature thermoplastics require making a mold first.
It's amazing how much technology goes into just the materials themselves. Now, another obvious way to classify orthoses is based on the body part they're designed for. Support for your ankles can be very different from one for your neck.
Right. That's a straightforward way to categorize them. We have orthoses for the neck, often called collars. These can range from soft foam collars to more rigid plastic ones, and even to halo orthoses, which are used for serious spinal injuries.
Yeah, I've seen those. They look pretty intense.
They are. Then we have orthoses for the trunk, often called back braces or corsets. You have SOs, LSOs, TLOs, TLSOs, and even more extensive ones like STOs, STLOs, and STLSOs, all supporting different areas of the spine.
So like a whole alphabet soup of acronyms.
Right. Then you have upper extremity orthoses, which include all sorts of splints and supports for the shoulder, elbow, humerus, wrist, hand, and even individual fingers. And finally, lower extremity orthoses. These include things like foot orthotics or shoe inserts, knee braces, hip orthoses like the hip spica, which is often used after hip surgery. You have AFOs, which are ankle foot orthoses, KFOs, which are knee ankle foot orthoses, and HK AFOs, which are hip knee ankle foot orthoses, providing that full leg and hip support.
So it's really like a whole map of the body with specialized support systems for each area.
Exactly.
Now, another way the sources categorized orthoses was based on the specific medical condition they're used for, which really shows you just how many different applications they have.
It really does. We see them used in cerebral palsy, hemiplegia, CNS diseases, MS, polio, muscular dystrophies, and various rheumatic diseases. They're also used in fracture bracing and postoperatively in orthopedic surgery. And within those broad categories, you have orthoses for things like CP, spina bifida, arthritis, diabetes-related foot problems, spinal cord injuries, strokes, traumatic brain injuries, peripheral nerve injuries, ligament and tendon injuries, fractures, developmental hip dysplasia, and even clubfoot. The range of applications is truly amazing.
So really tackling a whole spectrum of medical issues.
Absolutely. And finally, they're also categorized based on when they're used, which is also really important from a practical standpoint.
Right, because when you wear it is going to impact, how it functions in your daily life.
Exactly. We have nighttime orthoses, also called resting splints, which are worn while you're sleeping to maintain alignment, prevent contractures, or provide gentle stretching.
So kind of working their magic while you sleep.
Exactly. Then you have daytime orthoses, which are designed for functional support and mobility during your waking hours. And then there are some that are designed to be worn both day and night, providing that continuous support.
So a 247 kind of thing.
Right.
Well, this has been a really fascinating deep dive into the world of orthosis. It's so clear that these devices are so much more than just simple supports.